short as the Ewok.
Okay, we're going to get started today. So, focus with me. We're going to do a review of statistics. We're going to start with how many children are in your family, like siblings. But you're going to include yourself. Does it include me? Oh, well. So, I'm going to actually start this. So, in my family, we had 6 kids growing up. I was the second to youngest, but I would say I'm the favorite. Okay. Mindy, let's work our way around. Just tell me how many kids are in your family, including yourself.
4.
Awesome. Now come on over.
3.
And work your way back.
3.
3. Wow.
4. 3.
Nice. Yes, David. Man, where you been? Number of siblings. How many kids are in your family, including you? All right, Antonio. Emma. And Braylon. You can count whoever you want to count.
Who's in your house?
Okay, cool. All right, so now, guys, when I'm looking at this, if I wanted to know what number was the middle, how could we figure that out? Well, first off, let's order it. So I'm going to have you guys help me with ordering it. We're going to go from lowest to highest, but I'm going to cross them out. So was there only one with 2?
Yes.
How many 3s are there?
1, 2, 3, 4, 5, 6, 7.
How many 4s are there?
2, 3. There's 3 4s.
And then there's 1, 2, 3 4s. And then there's a 4th right there. And then a 6 and a 7, 6 and 9. Okay, how many is that? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
There's no only children?
I guess not in this group. All right, cool. So now, when we're talking about, we're going over some basics of statistics here, okay? So now when we're talking about the middle, there's going to be 3 ways we can think about the middle. What are those 3 ways?
The middle?
How about mean versus median versus mode?
There's the middle, and then there's the middle.
So we call these measures of central tendency. That's a fancy way of saying, where's the center? Where's the middle? And the thing is, there's different ways to think about the middle. And that's what these come from. So what I want you to do is to turn to your neighbor. Which one of these do you remember? What does it mean, and how do you find it? Okay? Turn to someone and talk for a minute, and then I'll call on somebody.
The mean is the average. The median is either the middle or the highest and the lowest. I don't know. One of them is just the middle number, right?
Yes.
Okay. I think that's mode. And then median's the highest and the lowest. Or something like that. Added together. No, but yes, no. I don't know.
Okay, let's come together. I'm going to ask David and Brian. They were talking about mean. What did you guys say about mean? Awesome. So to find it, you add them all up, and then you divide by the total, right? What is another name for mean?
Average.
It is the average. And I'm going to put a little note in here. It's also known as the fair share. Let me tell you what I mean by that. We're going to talk about money here in a second. We might change it. But let's say I said, okay, everyone get out your wallet, and if you have any money, put it on the table in front of you. And I went around to Mindy, and Mindy already counted how much do you have?
45.
45?
I don't think it's the highest, though.
So then I go to Nellie, and I'd say, Nellie, how much do you have? And then I go to everyone and say how much you have, okay? Now let's say Nellie only has, I'm going to say $3. And let's say I go to Antonio, and he just worked a gig, and he has $100, okay? Now what I'm going to do is I'm going to take all that money, I'm going to add it all together, and then I'm going to redistribute it so everyone gets the same amount. We're going to call that the fair share, okay? Let's say the fair share was $10.
It's either super good for the outliers or super bad for the outliers.
How would Mindy feel about $10?
I would be losing money.
Losing money, not happy. How about Nellie?
Making money.
She's like, hey, I'll take that. Antonio would be very upset, right?
That's
But
like
that's why it's called the
90% profit.
fair share. It's not necessarily fair for some of them, but it's giving everyone an equal amount. Okay? That's how you do mean. All right, let's switch gears here. Isaac, what about median? Do you know anything about median?
No, I don't.
Does anyone out there remember what median means?
Is it the max and the minimum added together and then divided in half?
No. So the median is actually going to be, I'm going to put the midpoint.
Oh, that's the middle. Okay. I got median in mode. I knew one of them was that.
Now, it kind of depends here, because if you have an odd number of people, then one will be in the middle, right? So you just look which one is right there in the middle. That is going to be your median. But if you have an even number, well, then when I get to the middle, there's going to be 2 in the middle. So what should I do with those 2 middle numbers?
Do the number between them.
Exactly. We're going to average the 2 in the middle. And we're actually going to need to do that with our data because we have an even number. So good job. That's median. Last but not least, we have mode. Is there anyone who can tell me what mode stands for?
Is this the maximum and minimum?
Mode is actually, so that's going to be one we're going to talk about later. It's called range.
Oh, yeah.
Mode is just referring to the most repeated,
Oh, so it's 3?
the one that we see the most. Okay, so now let's actually go to our data on the board. Okay, so we've got this number 2333333, whatever. I want you guys to take a minute and find the average. If you don't have a calculator, go and get one, or use your phone. But what we would do here is we would add all of these up and then divide by what? How many people did we get the siblings of?
Everyone?
Which is 14. I'll double check that. 2, 4, 6, 8, 10, 12, 14. So add these up, divide by 14, and that will be the average number of siblings, or kind of what we would expect someone to have.
What is the number I'm dividing it by?
14. All right, let's grab a different one. All right, for those who are adding it up, what did all of those numbers add up to?
Let me look at my history.
What was it?
54.
Did you guys all get 54?
Yes.
Awesome. So then what I'm going to do with that 54 is I'm going to divide it by 14. And what did you get?
3.9.
Point
85.
85. So we round that up to 3.9. And I'll put children.
Children.
Okay? That's how many siblings or how many kids are in your household, okay? Now, can you have 0.9 of a person? No, but what average means is kind of in the big spectrum.
It's like
That's-
you're supposed to have 2.5 kids or whatever. 2.6 kids.
and it's like, you can't have that, but that's our average here, okay? That's our mean. Now, the median is going to be the midpoint. So I'm looking which one's in the middle. And so if this is my data right here, how I like to do this is I'll say, I'm going to cross off the max and the min, and then I'm just going to slowly work my way, crossing off those bottom and top ones, until I'm left with either just 1 in the middle or 2 in the middle. In this case, since we had an even number of people, there was 2 in the middle. So I just need to average those. But what's 3 and 3 going to average to?
1.5, 2.5, 3.5, 3.5.
Okay, pause. How do
3.
you do an average? 3 plus 3 is 6, divided by 2 is 3.
3.
So you're basically finding the middle of those two, which is they're right the same number, so it's going to be 3.
Sounds like my 8th try.
So the median here, or the midpoint, is going to be 3 children. So notice that's lower than what the average was.
I think if we remove the 9, then we'd have more.
Now, that is a great point that I want to bring up. In math, we have what are called outliers. What does an outlier mean?
They don't fit the norm. They're
It's
hashtag
an observation that's
different.
really big or really small. It's kind of different from the others. Did we have any outliers on here?
9.
That 9 was a lot larger than any of the other ones. Now, if we took the 9 out, it's actually going to influence our mean more than it influences the median. Because the mean, this is a non-resistant measure. What that means is it's influenced by outliers, whereas a median is not. You don't really need to know that too much right now, but that's something we talk about a lot in statistics. Okay, let's go back. What was our most repeated one here, guys?
3.
3 was our mode. It was the most repeated. Okay, that's how you find mean, median, and mode. Do you remember doing this before? We're going to do practice, and then I'll eventually show you how to do it on your calculator. Okay? Now, go back with me a slide. One of the things we should have started off was discussing the difference between categorical data and quantitative data. I want to start with the quantitative data. Quantitative data means it has a quantity. Do you know what the word quantity means?
That's how much is in there?
It's an amount, right? So in other words, like if I said, hey, what's a quantity? So let's say Braylon's at like Home Depot, and they say, hey, what's the quantity on that shelving or whatever? And she'd say, oh, she'd give a number, right? The quantity is an amount. So this is data that is numeric. Numerical data. But I'm going to add a little side note. I'm going to say that makes sense to average.
What doesn't make sense to average?
Good question. We'll talk about that.
We average everything.
So, for example, if I said, what is your height? Would you give me a numeric response?
Yes.
Would it make sense for me to figure out the average height of this class?
Yes.
That would make sense, right? So height is a numeric variable, so it's quantitative. What if I said weight?
Yes.
Would weight, is that numeric? Yes. Would it make sense if I said the average weight of this classroom? Yes.
Yes, I guess. I feel like none of us would match it unless all of us would say. Same with height. Technically the average, none of us could be that height.
It could be.
Because like the average height, yet none of us are that height.
Now, let me ask you this. What if I said, what is your phone number? Is a phone number numeric?
Yes.
But would it make sense for you to tell me your average phone number?
No.
So this is actually not.
We could do
a
it yes, no
quantitative
with the
data.
area code. If you have 801 or 385.
I mean, that would help, but that's still, it's not, finding the average doesn't help you. So that's an example of categorical data. So categorical data, it's data that gets placed into categories, okay?
So the categorical is yes, no answers?
It can be, but let me give you some examples. So for example, categorical data is data that fits into categories. So if I ask you, what is your favorite color? Well, you could respond with a color, right? You'd say yellow, red, green, mauve, burgundy. And then I could go and say, well, how many people like this color versus how many people like this color? And we could compare that. Or if I said, what is your ethnicity? Okay? You could respond with different ones, but it wouldn't make sense to talk about averages or things like that, right? Ethnicity. Man, I'm like messing that up.
But with the Disney World, Disney Park question, that could be an average.
Well, no, so that's a good question. So on the board, the first thing I asked you guys was, how many of you have been to Disneyland? Or Disney World? So let's actually do that one real quick. There's 14 people here. Raise your hand if you've ever been to Disneyland or Disney World. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that would be 11 out of 14. Now someone might say, but those are numbers. Well, no, you're asking someone a yes or no. Have you been or have you not been? That's a category, right? So this would be categorical data. So I'm looking at the proportion of people who have gone versus the proportion who have not gone. So that's an example of categorical data. Last example is zip code. Now someone could look at zip code and say, but that's numbers.
Numbers.
But does it make sense to have an average zip code?
No.
Would that tell you anything valuable? It would not. So remember, if it's numeric, it's quantitative, but only if it makes sense to take the average of it. So when we were talking about your siblings here, is that numeric or is that quantitative, numeric, or is that categorical?
Quantitative.
Would you agree? Did it make sense to look at the average number of kids living in a house? Yes, that did. Okay, cool. So now, let's go. I'm going to teach you 3 more things, and we're going to do a different example.
Can we do the money?
Yes. Maybe.
Maybe.
Okay, so now we're going to talk about range. Jade, you were talking about range before. How do we find range? Awesome. I'm going to write that as max minus min. So our biggest number minus our smallest number. So for our sibling example, what was our highest number?
9.
And what was our lowest number?
2.
So I would do 9 minus 2, which is 7. That means all of our data is spread out over 7 values. Okay? That's the range. Now, I'm going to get into what is called quartiles. Okay? A quartile is just what it sounds like, quarters. It's going to split the data up into quarters. So, let me actually write this out here, okay? So we've got, I'm going to go like this, splitting the data into quarters. So I'm gonna have my minimum value, and then I'm gonna have my maximum value. Now, if we're thinking percentages, if the minimum is the smallest, it's going to be 0%. Okay. Now, what does that mean? The maximum would be
100%.
Now we talked about how the median is going to be right dab in the middle. What percent would you give the median? That would be 50%, right? And then what I'm going to now do is I've split it in half. Let's split it in half. Again, what's half of a half?
25.
25%. So my quartile 1, that's going to be 1/4, which is 25%. Then I'm going to have 3/4, my quartile 3, which is going to be what percent?
75%.
All right. So when we're talking about quartiles, what we're going to do is instead of just splitting the data in half, we're going to split it into quarters. Now, to find quartile 1, what we're going to do is take the median of the lower data, the lower half of data. And that means to get the quartile 3, what we're going to do is we're going to take the median of the upper half of the data. So let me give you a minute to write that down, and then I'll show you what that means. And then we're going to do a money example. Money.
Money.
Alright, now some of this depends on if you have an odd number or an even number for your median, but we're going to do both examples. So here's what I'm going to do. Here's my data. I have 14. Since I have 2 in the middle, I'm going to split those in half and say, okay, this is my lower half here, this is my upper half here. So how do we find the median of the lower half? You're just going to look at the middle here. So I'm going to cross off that one, cross off that one, cross off that one. And what's left in the middle? 3. That means 3 represents my quartile 1. Then I'm going to come up here to the top half of my data, and we're going to cross off the smallest and biggest. And then keep crossing that off until we get the middle, which that will be quartile 3, which is 4. Does that make sense how we did that? I just found the median of the bottom half or of the top half. Now let's actually fill all this in here, okay? So our smallest number was what? 2. And our biggest number was 9. Our middle number was 3, wasn't it? Our median. And what we just found was quartile 1 was 3 and quartile 3 was 4. Is it okay if quartile 3 and the median are the same? Yeah, it happens, especially if we have a lot of readings, okay? This, what I just filled out right here, this is called our 5-number summary. Because it gives us 5 numbers that basically tell us how spread out the data is. It gives us our 0, our 100, and our 50, and then our 25 and 75. How spread, and it kind of just gives us a good understanding of where the data is. Alright, now the last one we're going to go over here is called the interquartile range, or IQR. I just put IQR because I don't want to write the whole thing out. It sounds complicated, but it's super easy. All you do here, it's just like the range we did before. Range was max minus min. But now we're just finding the difference in our quartiles. So I'm just doing Q3 minus Q1. What did we say Q3 was?
4.
And what's Q1?
3.
And that gives me 1. So my range for all of the data from 100% to 0, that was 7. But the range from Q3 to Q1 was only 1. That tells me there's a lot of data in the middle that are really close together, and the data on the outsides are really spread. Alright, so that's how you come up with those ones, and those are the main ones we're going to look at. Now, I'm going to change gears, and we're going to talk about money. Maybe. Do you have, sounds funny to say that, but do you have money on you? Like in your wallet, do you have money?
Yes.
I don't really carry cash anymore, I just use a card. But if we have like 8 people that don't have any money, this will be really boring. So raise your hand if you have no money on you at all. Coins can count.
Yes, I'm counting my coins.
Okay, cool. Let's do that then. I'm going to give you a minute here. I want you to count how much money you have on your person, okay? Yes. Yes, but hurry, were you 0 or do you have any money?
No, I don't have.
You're 0, okay, yes, go 0. Everyone else count up how much money you have. Then we're going to come up with analyzing that data, okay? You got $2? Nice.
Okay, maybe I do
Better
have.
than me, I don't have any cash at all on me.
Wow, you're one of the boring ones, Soldier, messing up our experience.
We're going to just say cash. But you can use change. Change counts. So does everyone have a count? Shouldn't take too long. I'm
It's
going to
hard
start
to
with
count
Mindy over there.
coins.
Mindy, what was your count?
1 second.
1 second is time, it's not money. But time is money, so can we count that?
Okay. 45, 46, 47, 48, 49. 49.
$49 for Mindy. Okay, cool. Then let's go to Louise. It's got a 20 on it. Okay.